The third lesson with respect to acids bases refers to two topics. The first is the pH scale, and the second one is acid-base indicators. So the pH scale is, pH stands for power of hydrogen, which represents the concentration of the hydrogen ion found in solution when we dissolve something. The word power means it's a scale in multiples of 10. So a change in 1 on the pH scale means that there's been an increase or decrease in the concentration of the hydrogen ion by 10 times. For example, if the pH changes from 5 to 4, what that means is we have a 10 times increase in the H plus ion concentration. In contrast, if we're going from a pH of 8 to 10, first of all, that's 2 units on the pH scale, so that's a times 100, so because that's 2 units on the pH scale, so that's 2 zeros. And because we're getting into bigger numbers, that's a decrease. In the concentration of the H plus ion. Now, for your class grade 10 textbook, page 272 is where you'll find a scale for that. Probably a good idea to copy the scale down, or at least have a good look at it so you get a sense of what the scale range is. But it goes from 0 to 14, and you have a range of acids on the one side and bases on the other. If it's an acid, the pH will be less than 7. If it's a base, the pH will be above 7. And if it's neutral, it's actually at 7. So 7 is the dividing line. What we find is that anything in the range of about 4 to 10 on the pH scale is fairly safe to handle. It's not overly corrosive, so it's fairly safe and easy to work with. However, anything in the 0 to 2 range is very acidic. Anything in the 12 to 14 is very basic. Either end of the scale at this range, they're usually pretty corrosive. So we have to be fairly careful with those. That's where we got to start using gloves if we're going to use any significant quantity. Moving on in 3, 2, 1. Identifying acids and bases are what we're going to be doing during the lab that we're going to be doing in class. First of all, chemical indicators are things that change color depending on their surroundings. And many of you are probably familiar with these, so here's an example of one of the company's test strips. And on the back, you've got a scale that talks about the different colors and what that means for each of the chemicals that we're talking about. Different company, different scale. And so all you do with the test strips is you take it out, and they say they want the handle at the bottom, so you just line it up, and you say, okay, based on the color, I've got this much of whatever. And one of them is always pH. So, some indicators are specific for acids and bases. The ones on the test strips, some are for chlorine, some are for bromine, some could be for the stabilizer, whole range of things, but we're going to focus on the acid-base ones. There's an assumption that all acid-base indicators change with a pH of 7. That's not always true. The ones we're going to work with in class or have worked with already, some of them do change pretty close to pH 7. The bromothymol blue we've used in class changes right around 7, so that's good. Some of the other ones we're going to use aren't going to change quite there. Now, the way we're going to use these is some come dissolved in a liquid like the bromothymol blue that I've used. Others come in test papers similar to the test strips used in pools that you can just dip into a solution. The main difference between the two is if you dip it in, it doesn't matter what color the solution is because you're going to pull it out and look at the test strip, and that's going to tell you whether you've got an acid or a base. Any of the ones dissolved in liquids, you have to put a couple drops into the original solution, so if the solution itself has a color, it's going to be harder to tell. In class, we're going to be doing some testing of common substances. That means that I'm going to pull out probably about 15 or so household type products that you might find as opposed to lab chemicals, and we're just going to test them to see what things happen to be acids and which things happen to be bases, and can we see any patterns to them. That's going to be done in class on our next school day. For those of you who want to see a lab similar to it, there's one in your textbook. I believe it's section 7.4. You can take a quick look at it, but they talk about using universal indicator and cabbage juice for the indicators. I don't intend to use either one of them. And what we're going to do is we're just going to be doing more of the part B aspect, which is testing to see whether things are strictly acids or bases and not specifically where they are on the scale. And we will talk more about this in class tomorrow. Thanks for watching.